All right, class. Today I'm going to try not to lose my voice. I was doing some vocal exercises in the car, so hopefully this will work out okay today. So, anyway, today we're going to just quickly kind of tie things together and go kind of backwards. I'm going to give you the root. Well, the first one we're going to find the roots, but the last three I'm going to give you the actual zeros or roots of the problem, and you have to come up with the polynomial function that those came from. So, first thing, find the roots. Well, we learned yesterday that first thing we'd like to do is go to our graph to see if we get any nice roots. So let's take a look at the graph. Okay, so here's the graph. When you look at it, you can see that it goes down, it just touches there, goes back up, and then goes down through the 0 there and back up. I'm going to make my y2 to be 0, which it is. Now, one thing I want to show you guys. You can look at your table just to double check this one. When a 0 bounces like this, and let's look at that. Let's see if this will give us the intersection point. Sometimes it won't. Hit down, by the way, to move on to the y equals line. Sometimes it won't give you this because it just touches it, so you can see kind of what it is. Let's see if it gives it to us. Yeah, it did. Okay, this is basically -2. -2 comma 0. And that is a double root because it bounces. When a root bounces, it means it's like it's being squared. Alright, so I have -2. I'm going to go over to these over here just to double check. Remember, if they're not nice, we have to synthetically divide and then factor, or then use quadratic formula at the end. Okay, 4, so that's a nice one, which means that the last one will also be nice because we can't have a non-nice one by itself. So this is actually a very easy problem. You guys don't have to do anything else except for get the numbers. So we have -2, 4, and 7. So here's what that looks like. Oh, I lost my paper. Okay, hold on. So basically x equals -2, 7, and 4. This one is a double root. Okay? So I found the roots. I kind of answered my question, but if I wanted to write a polynomial function, which I'm going to do here, and actually it should be polynomial function, what I'm going to do here is f of x is equal to, well, if x equals -2, that means that the factor is x plus 2. That's how you get x equals -2. And if it's a double root, that means it's to the second power. X minus 7, because that's how you get the root of 7, and x minus 4 gives you a 0 of 4. So this polynomial function, if you multiply this out, will give you that. Okay? Actually, I didn't have to come up. I just realized we had the function. What I was doing was I was writing it in factored form. So this is this function factored all the way completely without using any other method except for using your calculator. So again, you can use your calculator first for factoring, and then you might need to synthetically divide if possible. Alright, so writing a polynomial function. So now I'm giving you the roots, and you're writing the function. Well, first things first, let's write these as if x equals 3, x equals -5, and x equals 2. That means my factors are x minus 3, x plus 5, and x minus 2. Now, but this is not in polynomial function form. It has to be in descending order. So what you have to do is now multiply this out. So I'm going to multiply these ones out first, and you get x squared minus 3x plus 5x. So you get f of x is equal to x squared minus 3 plus 5 is a plus 2x minus 15. And we're going to multiply that by x minus 2. Okay? So now I'm going to multiply this out. X squared plus x is x cubed. X squared minus 2x squared. 2x times x is plus 2x squared. 2x times minus 2 is a minus 4x. Minus 15 times x is a minus 15. You guys should be able to do this on your own, hopefully, at this point, and then plus 30. Now just simplify it all the way. So my function for this problem is x cubed the x squareds go away, and we have minus 19x plus 30. And that's it. So we just came up with the function that gives us the roots of 3, -5, and 2. Now, with number 2, there's a little wrinkle thrown in. We have an imaginary number. Well, remember, complex means that we have the answers, they'll have a plus and a minus 2i for our answer. So I gave you 2i, you know the other 0 is minus 2i. Okay? Well, with imaginary numbers, we don't like to put it in parentheses right away. What I like to do is, again, over here I'm going to say, well, x equals 3 and x equals 2i. Now, to get this factor, again, we get x minus 3 equals 0. And there's our factor. That's how we got that factor over there. Over here, though, we don't like the i's in the factors. So I'm going to reverse solve this, which means that I'm going to do the opposite of how we got here. Well, how do you get an I? You take the square root of something. So what I'm going to do is, I'm going to square both sides. And I end up with x squared is equal to -4. Which makes sense, because think about it. If you now take the square root, you get 2i, plus or minus 2i, which is where both of them come from. So, again, you don't have to do anything with the plus or minus because it is taken care of right now. This polynomial function, or this factor, will take care of that. So there's my other factor. So now I can write it out. F of x equals x minus 3 and x squared plus 4. And when I multiply that out, you get x cubed minus 3x squared plus 4x minus 12. And there's nothing to simplify. That is the final answer. And the thing is, again, it's an x cubed, which should give you 3 answers. One of the answers is 3. The other answers are plus and minus 2i. If I only give you one of them, it's okay. You can still do the problem. It just, you have to remember that there's also a second one at minus 2i. Okay? Alright, so that's that one. Same thing for this next one. Last thing we're going to do. This imaginary piece also has a second piece to it. Remember, there's 4. So this final polynomial, you should be able to tell me, will have 4, or it'll be x to the 4th. Because we have plus and minus 3, so that's 2 answers. We have 2 plus I, and then we should also have 2 minus I. We should always have its conjugate. Now, here's what you do here again. We don't like it in this form, so I'm going to move this over and like reverse solve it again. So, if I move the 2 over, I get x minus 2 is equal to I. Now I can square both sides again. You always want I by itself or with a number in front of it, but not with a plus or minus. So, I'm going to square this whole thing. And I get, well, when you square x minus 2, you get x squared minus 4x plus 4. Actually, I don't need parentheses anymore. So that's the left side, and I squared is -1. So finally, to get it into a factor, you just move the -1 over and set it equal to 0. This piece, if you solve it using completing the square or quadratic formula, hopefully you guys see that this is kind of like reverse completing the square. I'm squaring it, I'm adding the number back over, and now this is my factor. This factor is my quadratic piece. If you use completing the square or quadratic formula, you will get the answers 2 plus or minus I. Okay? Again, we're just working backwards now. So, I have my pieces now. I have that, I have x minus 3, I have x plus 3, and then I have this factor that I just found, which takes care of my other 2 answers. This is better than doing this. Some of you guys are like, well, why can't I just do x plus 2 plus I and x minus 2 plus I? Actually, I shouldn't do it that way. It should be x minus 2 plus I and x minus 2 minus I. Okay, and yes, technically you can do it this way, but then look at foiling this out. You have 3 pieces, it's a mess. This way, so don't do this. No. Yes, for this one. Okay, You want to reverse solve these to make life a lot easier. That's a lot worse. Even though the book, I think, does it this way. But, again, not worth your time. Alright, here we go. So now we just have to multiply this out. I would recommend doing these two first. This is just the difference of two squares. So when you multiply that out, you should get x squared minus 9. Those are conjugates. And then we have x squared minus 4x plus 5 is our other piece of the puzzle. And now I'm going to multiply that out. I have x to the 4th minus 4x cubed plus 5x squared minus 9x squared plus 36x minus 45. So my final answer is f of x is equal to x to the 4th minus 4x cubed. We have a plus 5x minus 9x, so that's a minus 4x squared. And then we have our plus 36x minus 45. And that's our final answer. This polynomial will give you zeros of positive and negative 3 and 2 plus I and 2 minus I. And we will have 4 answers for that. And you can always double check your work if you have time. Throw this polynomial function in your calculator. Double check to make sure that the zeros actually cross at negative 3 and positive 3 and that it doesn't cross anywhere else. You can use synthetic division to work your way back to these pieces. Okay, and that is it.